Hi, my name's Tom White, and today I'd like to have a conversation with you about project and problem-based learning and how it's applicable to today's students. Today's students have so much access to information, it's really difficult for them to sort it all out. And what we need to do as teachers is to help them learn how to learn and learn to dig in deep and pull the information that they need uh, just in time so they remember more of it. So, good project problem-based learning always begins with an essential question. And so today's question for this discussion is why project-based education is a big deal. And of course, along the way, we have some guiding questions, or sometimes they're called key questions. And these are questions that students have asked for generations. It's why do I need to know this, and where will I ever use this? So let's begin with what it is. So in order to be effective, a good curriculum defines what it is that we should teach and then creates a roadmap for doing that. And the roadmap walks us through all the different things that we as teachers and administrators need. Learning standards, the approach, the day-to-day type of thing. So we want to make sure that if we write a curriculum that's project-based, that the students are actively involved in projects all the time, and that they follow a roadmap so they have good chance of success. So the first thing we have to do is to focus on rigorous and relevant problems. Students need to understand what they're working on, and that makes it relevant. So if it's relevant to their life, or to the lives of their friends or relatives, they'll be interested. And so what we want to do is to make sure that they're working at a high level. And if you pay attention to Webb's depth of knowledge, that'd be levels 3 and 4. So we're always creating, we're applying, we're analyzing. We worry more about that type of learning than we do about being introduced to something. The teacher acts as a facilitator or coach. The learning process itself is dictated by students. Their teams decide, what it is that they need to work on. So they refine their problems. They define what it is that they need to know so they can go start researching. They share information with one another. So these teams that we put them in are really basic to this type of education. It's a little noisier than a standard classroom, and sometimes the teacher doesn't feel as in control, although more learning is taking place. So the teacher acts as a guide, going to different groups and just kind of, answering questions with questions to kind of guide them on their journey rather than to tell them the correct answer. So we call those cooperative learning groups. So they have a group that is their initial support, and you'll find that after a while, the students love to support each other. They like to talk to each other and basically show what they know on a regular basis. So the nice thing about this is each problem that's given to the students has multiple right answers. Students, rather than trying to remember vocabulary and spit out just a one piece of information, they're coming up with a whole process. And, we're looking at the process rather than the actual product. So we all start with an essential question, and then the guiding questions continue on throughout. And then we evaluate the whole thing when we're done. So there's a couple of forms of evaluation. One is formative. As we go through, students are giving us written feedback and oral feedback. They're doing metacognition, which is really the term we use when students are evaluating themselves. And what this does for students is allows them to really truly analyze what they're doing. And finally, there's summative evaluation. So at the end of this course, the students can sit for a certification exam and earn certification in Solid Edge. So I want to talk a little bit about what does the classroom look like? What are the types of things that the students are going to be doing? And this slide is a composite of pictures. The students were trying to design something to maintain a constant temperature. And so you'll see that almost every project begins with a pencil drawn sketch where ideas are put down quickly and evaluated, and then they work their way through a more formalized documentation process. So in this case, they're creating a program to maintain things, to take sensor data and multiply it out so it's in a format that they understand. So as we move into this, we're always looking to what are the things that students really need to know. And so if you start thinking about all those things that they need to know, and I know we've talked to multiple industries and colleges and universities and said, well, what do you really need from the students graduating from, like a program to come out with? And they give us a lot of the soft skills, what was known for a while as the 21st century skills, working in teams and being self-starters and, digging in and being kind to one another. It's not always easy for students, but basically they want students who not only have a knowledge of technology and how it's applied, but how to relate with other people, how to manage a project, and how to communicate at the very end. This is almost critical for all industries, for the people that they hire. And so as we look at it, we force students into presenting a lot. Every project has a presentation component. This was a school I visited in Arkansas, and what they had done is they had taken the gymnasium and set up a series of tables around the room, and they invited the community to come in to tour around, stop and ask questions about what was going on. And basically it allows for adult feedback to the whole process. It is hoped that, by going through this and learning how to communicate with other adults, they open up their, prospects for future employment. They learn more about what people in the communities do, what kinds of skills that they're looking for. It's easy for a student to ignore a teacher because they're always with them. But, if you have a local judge that comes into the classroom and starts to talk about what are the things that he sees in the community and the things that he thinks the students need, they pay attention. And even the simplest things, like, for example, this was a reverse engineering project that the students went through. And one person decided that they wanted to take the sample clothespin and reverse engineer it. So they basically did some sketching, and they took measurements. You see this very often, in field technicians. They go off and they have to create sketches in order to do some field documentation before they bring it back to the lab. So then they took it and they converted this sketch to a three-dimensional drawing and sent it to a 3D printer. And they printed out this clothespin. And if you look at it, you can see the layers that the 3D printer put in. And they said the hardest part was the spring, because it took quite a bit of research to figure out how to draw a spring, how to print a spring, a little trial and error. It's all good stuff. So really, when you think about what the goals of curriculum are, it's to create depth of understanding. So we keep digging and forcing the students into ever increasing levels. So they follow this design process through the whole thing. And the design process starts with something simple like defining what the problem is that they're trying to solve, because people try and solve problems without defining them. And they spend a lot of time trying to solve the problem and never getting there. So we teach them what to, process to use, and then we force them into documenting the whole thing, not only in notebooks and digital formats, but they create several documents along the way, and I'll show you those in a second. We have the students work in groups. You'll find these classrooms have a lot of whiteboards, or sometimes they use Post-it note paper. The students work together and they do a lot of sketching. And if they're keeping a digital portfolio, they take pictures of the boards so they can record the whole thing. We provide resources to students to get them started, because sometimes there's some advanced concepts we want them to understand, and the basic resources provide what we call essential or dependent vocabulary. So when they start talking and writing about solutions, they're using correct vocabulary. So when they're actually presenting to authentic audiences, they're using the right verbs and nouns. So basically, we're putting this all in a context for students. They realize that they have to work together. They have to respect one another. They have to communicate. And you can see that, this group of young folks were, starting to draw on a board, and rather than having to share one pen, they passed it back and forth for a while. And then as I watched, they just picked up more and more pens. And so they all started, writing on the board and sharing ideas. And that kind of interaction really changes the dynamic of how they learn. Now, what you're looking at was a sorting device that some people designed, and the goal was to sort two different sizes and have a machine that would actually split them up and put them in the right bins. So they had an awful lot of things to define. And in this case, they were working on a mechanism, and they started writing down on the plywood that the whole mechanism was screwed to. So they had a place where they documented the whole thing to remind them of what they were trying to accomplish. Of course, they had to take a picture to include in their notebook. So I had them give me the picture. So this is a classroom where they put it on like large Post-it notes and stuck them to the walls. There was no whiteboard in the room, so they had a chance to actually do some documenting along these lines. And as you might have noticed, that the pictures were probably taken before the pandemic, so they could actually get close to each other and share and touch and that type of thing. And, we'll get our classrooms back to that point soon. So when we take a look at the long-range goals, we want graduates who come out being lifelong learners. In other words, they know how to learn. And when they go to work for somebody, generally they're given a task like solve this problem, or we need you to work on this, communicate this to our clients. There's no multiple choice test to get your paycheck. It's all about, can you communicate? So this is another presentation that was done in a different state, but along the same lines. It's just a way to communicate. And so here was a classroom that I visited. I believe it was in West Virginia. And, it was the smallest classroom I think I've ever been in where they tried to use it as a design lab. And the teacher was just spectacular, because she could divide these students up into groups, and they worked together and they communicated and they shared, and it wasn't easy. And if you'll notice, there's whiteboards that ring the room. And so everybody got a chance to write on the whiteboards, and they shared their mathematic formulas, and they wrote and they followed all the things that we wanted them to follow. So the Siemens curriculum is available at no charge to schools. The software is available at no charge to schools, and training is available at no charge to schools. So basically, you can download the curriculum, and once you download it, you get involved, and you'll see that basically the students are engaged in a design process. And I tell people that there is no the design process, it's just a process. And once students learn this process, they apply it to all kinds of things that they're working on. So we work, and every project, is based on the design process. And each project has a list of things that are included in it to make the teacher's life easier. So there's an introduction, there's a purpose, concepts, all the way down to the daily plan, where it walks through the design process from defining the problem to creating a presentation to deliver to the authentic audience. So this design process I've been talking about, they're going to research, and this gives them basic background information. Once they have the background information, they define what it is that they need to learn. They go off and learn that. They create some written documentation to exchange with their customers and clients to say, is this really what you want us to solve? And then it's that give and take where they further refine what they're working on. Then they design, build, and test. And part of the design phase is to create a testing protocol. So they're saying, this is what we want to test for. At the end of that, after they design and build their prototype, then they can test by a protocol that they defined as answering the question, not evaluating their prototype. So they can evaluate the prototype against the question that they were trying to solve. Once they do that analysis, they go back and they say, well, did we answer the question? Did we come up with a solution? If not, we need to tweak here, we need to redefine, and that type of thing. And so that's the iteration part, where we go through it again and again until we come up with something that works. We finalize all the documentation, and then we communicate that design idea to folks. And so now I'd like to take a closer look at the curriculum because you can download it for free. And I want to show you a few things about it, what it means for teachers, and how it's used. What you're looking at right now is the PDF of the curriculum document. And you'll see that there's a lot of choice and the ability to walk your way through it in a number of different ways. And the reason for that is different people are excited by different things. And if we give them enough choice, they'll be excited by something. So you're looking at the first quarter, and what this is going to do for us is to provide a roadmap. So the very first thing we want people to understand is this design process. And the first project really just deals with the design process. And the second project deals with sketching and creating documentation. So the first thing we teach is like how to keep an engineering notebook and what various documentation that is required when you create a solution to something. We teach them hand sketching. I know when I was working in industry, we had cases and cases of old table napkins and tablecloths and things where we took basic sketch pads and we took notes and documentation, and we saved all that in addition to creating the digital format of drawings and design. Then the very third project, which is where we come in and we start teaching three-dimensional modeling, is a 3D modeling, fabrication, and printing end of things. And it's a nameplate holder. Now, what I've been seeing is students get started, they engrave their name on things, and then they build in a cell phone, station to drop their cell phone in so they can charge it while it's sitting on the desk in front of them. Then we give them a choice of different projects. And in this case, they can either design a sport drink container, kitchen tool sets, a chess set. And so different members of the team are working on different things, but they have to have a common theme. So they work with each other and have those discussions. Later on, we learn about photorealistic rendering. So you take your solid model and you can create things that look like photographs, complete with backgrounds and lighting and that type of thing. So we can better communicate what it is we'd like to see. We talk about table-driven parts, measuring implements. So basically you have one shape, but different sizes driven by an Excel table. Because one of the things the college people told us was the lack of Excel experience that young people had when they were coming in. And it's also something that employers look for. If you're going into any technical field, the ability to use the Excel spreadsheet program really is a tool all by itself. And then there's an optional project that will really kind of take your advanced students and drive them through distraction. And that's a product design. So in this case, it was a tennis ball box, so they could build a box for something so it could be stacked on a shelf. And so they follow along through. And then as the course progresses through, you'll see one of these table of contents with pictures for each quarter. So it's a full year course. So it gives you something to do. But I'd like to just tap into this first project. So every project has the same layout. So if you're looking for something, you'll find it in the same spot in every project. So there's an introduction that will basically tell you what the project is about. Then there's a purpose. Why are we putting the students up to this? All right, so we have defined the learning that we want the students to use, a paragraph on what's important. Then we get into the concepts. Now, these are concepts that Dr. Blaze and I wrote specifically for these courses. And you will see that, if you're familiar with Webb's depth of knowledge, that all the verbs are really level 3 and level 4. They require quite a bit of background and knowledge. It's not a question of, do you know just the words, but, how do these all interact? The standards. So, basically you find these are the engineering design process standards that we created for this, where they're creating and applying. We included the standards for reading, writing, speaking, and listening. And in this way, if you have to, I know when my daughter was an art teacher, 50% of her evaluation every year was how well the students did on their standardized testing. So these are the types of things that you could say, my curriculum helps in the standardized testing in these ways. We get into the next generation science standards, or, how are these pieces, all relate to the engineering standards of the science standards. We include the standards for technological literacy, because those are the standards where state directors, if they want to find out if a piece of curriculum meets the standards for Perkins funding, those are in there. You remember that curriculum is written for many audiences. Then we talk about assessment. Now, in this first project, really what we're assessing are the written So, for example, if we go to this informational explanatory rubric, it shows us, well, here's how we're grading these pieces. We share this with the students right up front so they know that, oh, well, this is what we really are aiming for. So they are trying to answer as best they can. Then after we finish that, we get to our essential question. So in this project, it's how can our team come to consensus and produce a design to solve a problem? So they have to go through this whole piece. There's a student scenario, which basically tells the students what they're trying to solve and how it works for them. It assigns them a role. It helps them with their career explanation. It gives them deliverables. So, they know that they have to provide the teacher with an engineering notebook, an outline of the engineering report, data collected as part of their testing process, and they have to present this. And then there's a daily plan where we go through and they say, okay, you're going to watch this video from NASA, then you're going to go to the design process sheet. So if we go to the design process sheet, it takes them through all the various steps of the design. So they know up front what those are. There's a piece on how to, keep it all in your engineering notebook. Then they get around to the problem statement at the end of day one. So they're, refining what it is that they want to work on. They create a management plan. They create a design brief. And what you're going to find is each one of these pieces of writing that they're doing takes chunks of the last piece of writing they do. So it reinforces the fact that, however they're keeping their engineering notebook, either in a, classic notebook format or in a digital format, they can very quickly pull things out and reuse them. They design their testing protocol that says, okay, so this is how we're going to evaluate it. We're going to gather data. We're going to generate graphs and charts. And then we go on maybe creating a decision matrix to find out what is the best way to make a decision on these things. And then we're going to design an engineering report and then present it. The slide you're looking at shows what's available now and where to go to get more information, to download the curriculum, to have access to the free software, and more information about training for teachers. Thanks for attending. Well, I hope you found it valuable.